So I'm just going to go full screen right now. And okay, so present. So my name's Ethan, and I'm from Springfield, and I'm going to be a senior in Union County Magnet High School next year. Now, it's a reminder for all children under the age of 13, they should be accompanied for the parents for privacy reasons. It's the law. And do not post any information here, including but not limited to your full name, your address, your phone number, or your email address. We remove any comments revealing personal information. The review. So, batteries. They provide voltage to power our circuit. So, think of voltage as just electricity, and the more of it you have, the more components you can power. Then you have battery holders, and battery holders hold batteries so that we can treat multiple batteries as one. So in our case, we have two AAA batteries, and it's treated as one. So the power is doubled, so the voltage is doubled, and we're able to power all the electronic components. Without this, nothing would have enough electricity to actually turn on. Then we have resistors. They resist the current or the flow of electricity. So they just make sure that too much electricity is not put into into LED or a buzzer, so it will burn out and not work anymore. Then we have LED, light emitting diodes. They're basically little light bulbs. That's basically all you need to know. They have also the long leg is the positive side, and the short leg is the negative side. This will come into use later when we make the circuit. Then we have piezoelectric buzzers. They're what we're going to be using today, and they make sound from electricity. If you want a more detailed description, you can ask me later on after the session's over. Then we have buttons. They switch the current from open to closed or vice versa. Essentially, we can turn the LED or buzzer on or off by letting electricity pass through or not pass through. So now, concepts. So basically, closed loop forces electrons to flow from a positive terminal to a negative terminal, and only in that direction. And an open circuit does not let electronics flow through the components. So if a circuit is not completely connected, as you will see in our examples below, then it would simply not flow. So today we're only going to be using series circuits, but I'll just explain both of them for just knowledge's sake. Series circuits have only one path, as you can see, just a rectangle, and that's it. While parallel circuits have two paths. So that enables you to power more components with the same amount of electricity, because the voltage stays the same in both of the two paths. Now, the doorbell. So this is the final product, how it's going to look, and this is how this is what the wiring diagram will look like. So now, why do we need doorbells? This is very informative. So basically, you already have one for your house, so you don't have to put up signs like this. So how cool would it be if, in order to come into your own room or some other room like the living room, someone would have to press the doorbell, so you would know. You obviously don't want to be yelling ding dong very loudly. So, okay, we will need. So just make sure that you guys have all of this. And if it's optional, it is truly optional. It's just to make it more decorative. I'm going to give you guys 2 minutes to get the components, and after that, we will transition into the building projects phase. Okay, so first we're going to make the circuit, and it's not a terribly complicated circuit. It has 3 main parts to it. I mean, actually 4. So it has the battery that outputs the power through the red wire, as you can see. Let's put in the first component, the resistor. This limits the flow of electricity to make sure that some components don't break. I'm just going to attach it to the red alligator clip. And then, once I do that, I take another random alligator clip and I attach it to the other side of the resistor, because the circuit needs to be connected. Then, I take the buzzer over here, button over here, and I connect it to the other side of that red alligator clip. So as you can see, it's going from the battery to the resistor, now to the button. Last but not least, I connect a yellow or any, I mean, I'm going to use a yellow one, but any alligator clip to the button over here. Let me just open it up. Let me just, okay. And then I will connect the other side part of it to this buzzer, as you can see. And be very careful that you connect to the positive side of the buzzer. There's as you look on the buzzer and you'll see one side or one leg is labeled as with a plus, and the other one's labeled with negative. This alligator clip should be connected to the positive. Then I finish the circuit and I test it, and of course the buzzer works. So when I press the button over here, this, and of course when I turn the button off, it's off. So now we're going to transition to the next phase, and that's basically going to be the building phase. This is when your thin cardboard box comes in. So I have this amazing box, and I thought this is about the size that I want the box to be. So it can fit all the electronics, but it just doesn't dominate a gear that you put it on. Now, I'm just going to put the electronics aside for now. And I'm also going to take out a piece of tape and a piece of string. Okay, so I have a piece of string, tape, and a box. Okay. Now, okay, great. Okay, now that we have these three materials, here's what we're going to do. We're going to take this string, we're going to make this, maybe cut it to about a foot long using your scissors. Mine's already about a foot long, but if you don't have it a foot long, just do it with scissors. Then place it on top of your box, probably somewhere close to the top, so you have a bit of a hook, not hook, like a loop, and then you tape the string down, like so. Using, it doesn't have to be particularly strong tape. I have Scotch tape, not known for not known for being the strongest, but this works a-okay. And when I tape it, you should be able to fully just hold it up without the tape like letting it loose and breaking. So as you can see over here. So as you can see, I'm now waving this around. It works. So now after I put the string down, I'm going to do a bit of the optional decoration part. If someone has paper that looks nice, you can just wrap the box around in it. I'll do this very, very quickly. Just to make sure, you want to leave an opening to your cardboard box at the very top, so you can actually put the electronics in. So now that you have the box, the string, and the electronics, you can now put the electronics inside of the box. But there's a very specific way you should do it. You should basically have it so the button is in a way sticking out of the box, even though almost all of the electronics is in. So you just take the circuit, you put it into the box, like so. There's no technique to it. Just put it in. Try to take care of the electronics and not jam it in there too hard, but just gently put it in, just so you have this sticking out. And if I press the button, so you see I press this, and it plays. So, should probably, and by the way, the button that's sticking out, there should probably be about 5 inches of wire that's sticking out. So, like so. Okay, so if your box has a flap to close it, you're free to do so, but don't do it until you secure your button over here with tape, so it doesn't fiddle around too much. So just anyone who can walk up to your box, press the button, and you hear the noise. So there's also an extra thing that we could do. So I'm just going to tell you right after I close the box, to make it look even better in a way. We could just take a piece of paper, cut it up, and put it over most of the wiring, just so only the button's visible. This is completely optional though. I'm not going to do it, but to demonstrate, because it's just simply putting a piece of paper over the electronics. But if someone would like to make it look even better, then do your thing. And make sure when you close, if you close your box like I did, your string is sticking out, so you're able to still secure it onto the doorknob, like so. I'm going to demonstrate how the buzzer would work on an actual door. So this is how it should look. And if I'm going to have Ryan come over and press the button. And now you see how your doorbell would work. So if someone wants to come into your room, they press the button, you hear the sound, you say come in or do not come in, and boom. So what to do after making the doorbell? This is when you start confusing people. So you see this amazing person made a please ring bell sign and then said do not ring bell. So if you want to confuse all your friends, I mean not now because of the current situation, we can't have any friends over, but your family or something, then you could just take your optional writing utensil and just write on the box please ring bell and then do not ring bell. This is obviously just a joke, but you know. So now, once you have done this extremely important task, I would like to tell you that we're going to have another live stream on Saturday, August 15th, and we will be learning about motors with Jason. And I highly recommend it. He has some really interesting stuff to say about motors, and yeah, it's really good. It's going to be really good.